looking at number 6 from the homework. They didn't need to tell us that arc DCE was 180. We already knew it was 180 degrees because it's a semicircle. How did we know it was a semicircle? Well, chord DE is going through the center of the circle, and that makes it a diameter. And so it's definitely a semicircle. We didn't need that information. Arc DC is 70 degrees. Arc CF is 80 degrees. And angle DCF is 105. One of the theorems we learned yesterday said if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. Is that a quadrilateral? Check. Is it inscribed in the circle, aka are all vertices on the circle? Check. And so now I know that opposite angles are supplementary. So I can do this. I can do 75 there. Let's see. CFE, we don't know that one yet. FED, we know that one. I just found it. Opposite angles are sup. And EDC. So we need to find those two missing angles. And there's a couple of ways that we could do that. We could, let's find this one first. Let's find this angle first. Let's find this missing arc, which is going to help us. So I'm going to do 180, and I'm going to subtract the angles we already know. I'm going to subtract 70 and 80. So I'm subtracting 150 from it, right? What do we get? Thank you. You already had it. 30. Now, you have to be careful. When we use what we learned yesterday, an inscribed angle is half its arc. An inscribed angle is half the measure of its arc. But you have to follow the angle all the way to the arc and see where the arc begins and ends. So this angle that we're looking for is half of, not 30, not 80, but 80 and 30 combined. That angle is half of 110. Is everyone okay with this? I follow it with my fingers. I see how long the intercepted arc is, and I divide by 2. And then, of course, to get this one, all I need is the supplement of 55, which is 125. Thank you. So we were using that same theorem multiple times in this problem. Okay. All right, let's look at number 8. The measure of arc AT is 80. Measure of arc LE is 76. And the measure of arc ER is 134. Woo! Now, what we have to be careful about is we know how to find the measure of inscribed angles. We don't know how to find the measure of, let's say, this angle right here. Its vertex is not on the circle. So we need to be careful and make sure we're only using that theorem on angles whose vertex are on the circle. Let's start finding. Sometimes I like to just solve the whole circle and then go look and see what they were asking for. Okay? Here we go. So let's just start dividing some things by 2. I'm going to take 80 and divide it by 2, and I get 40. I'm going to take 80 and divide it by 2 and get 40. Do you see how both of those angles were intercepting the arc? You just follow the rays with your finger. You follow the rays of E with your finger, and you're pointing to the arc that you're supposed to divide by 2. Okay, 76 divided by 2 gets me 38. See, I'm just taking all of these, I'm dividing by 2, and I'm putting that number inside the angle that opens up to the arc. And 67. Oh, I missed one. There were 3 inscribed angles that were all opening up to 80. Do you see that when you follow it? Think of it as a spotlight, as a coming out of a spotlight or a flashlight. The light kind of goes like this, and so you follow what arc would it be shining on if it was a flashlight kind of thing. Have I found most everything that we needed? Found it, found it, found it. LAE. Haven't totally found that one yet, but let's keep going. This is going to be angle addition. I took 76 and divided it by 2. So 38 plus 67. And ear. Okay. Okay, sorry about that. I was finding LAR. LAE was not 105. I went above and beyond. It's 38. Backwards. We didn't need to do angle addition. I was overzealous there. Sorry, guys. Thank you, Aaliyah. Number 9. Here we go. You're going to see one like this on future quizzes. You're going to see one like this on your assessment. So let me start giving you some strategies. You're allowed to bring a highlighter with you to a quiz or an assessment. So I always start by highlighting the diameter because that divides my circle in half. So I know we've got 180 on either side of that diameter. The measure of arc AE is 120. I can stop right there and I can find ED. It's 60 degrees. You see what I'm doing? I'm using the 180. I'm using the semicircle. Measure of arc AB is 70. And the measure of arc CD is 40. I'm going to do it again. I'm going to add up 70 and 40, and I'm going to subtract them from 180. And we get congruent arcs, don't we? 70. Okay, so this is how I recommend you do this when you're trying to solve these problems. Step 1, find all of the arcs, all of them. Step 2, here's what I recommend next. I recommend you find all of the central angles because they're the easiest. Find all the central angles. 70, 70. Let's see, 110, 110, or we could have used linear pair. All right, well, that's all the central angles I have. Now we go to inscribed angles, and we find every inscribed angle we can. So I'm going to say a number, and I'm going to divide its arc by 2. Let's start with number 1. 40 divided by 2, 20. Number 2, 120 divided by 2, 60. Number 3 is not inscribed, so I'm going to stop for now. Number 5, 120 divided by 2, 60. Number 6, 40 divided by 2, 20. Number 7, 60 divided by 2, 30. How fun is this? You're just like a puzzle, and you're like trying to find all the pieces, and it's super cool. All right, finally here, of course, we use our good old triangle sum theorem. What is it, 100? Yeah. We know the angles of a triangle add up to 180. I'm not going to write them in the blanks. I think I found all the ones you would need to be able to solve this problem.